All right, here we are. We're working on the Chapter 6 review. We're talking about momentum and impulse today. And number one, if an object, here, I'll show right where the picture is. If an object is not moving, what is its momentum? Well, if momentum equals mv, if your velocity is 0, guess what your momentum is? It's 0. Number 5, back over here, 5. A gymnast always performs on a padded mat. Use impulse momentum theorem to discuss how these mats protect the athletes. Impulse momentum theorem, impulse being delta p, states that force times time equals change in momentum. It also equals mvf minus mvi. So if you're talking about a gymnast or any padding, the VI is some speed that they're hitting the mat with. The VF is 0 because they're stopping them. So this half of the equation is going to stay the same regardless of the method of stopping. It's over here that it changes. So if you're using a padded mat, you're going to try to increase the time of impact, which would in turn decrease the force of impact. And that's why we want to use padding with gymnasts. And then number 6 talks about car collisions with airbags. How does the airbag soften the blow? Again, the airbag is increasing the time of your head slowing down to stop instead of just slamming into the steering wheel or something. So increasing the time decreases the force. And then number 7, if you jump off the table onto the floor, you're likely to hurt your knees if you don't bend them. Why? Same exact reason. When you bend your knees, it's taking more time to stop you, therefore less force upon you. And 8, consider a field full of insects, which all have essentially the same mass. If the total momentum of the insects is 0, what does this imply about their motion? That tells you that if the total momentum of the whole field is 0, that means that all of the velocities of the individual insects are canceling each other out. B, if the total kinetic energy of the insects is 0, what does this imply about their motion? If the total kinetic energy is 0, that means that you can't cancel out kinetic energy. That must mean they're not moving. And 10, how do car bumpers that collapse on impact help protect the driver? So again, with the impulse momentum theorem, if you've got a certain VI of the car crash, maybe you're going 35 and you hit a pole or something, you're stopping no matter what, and you have your certain VI, so this half of the equation remains unchanged. However, if the front of your car is crumpling you to a stop, that means it takes more time for you to stop. Therefore, there's less force applied to the car and therefore you. And then let's do a calculation. Number 12. A 2.5 kilogram ball hits the wall at 8.5 meters per second. To the left, bounces back 7.5 meters per second to the right. If it happens for 0.25 seconds, what's the force? So we're going to use this equation right here. So the force times 0.25 equals, we'll put our mass down. Our VF is 7.5 to the right. So 2.5 kilograms times 7.5 to the right minus 2.5 kilograms times 8.5 to the left. Now, I'm not going to solve this one out, but I have it set up for you here. The big key on this is a sign. I'm going to choose to make left negative. So you'll do your multiplying, you'll add those up, and you'll divide by that to get your force. But this negative here is perhaps the key to the whole thing. Number 13, a football punter accelerates a 0.55 kilogram football from rest to a speed of 8 in 2.5 seconds, or 0.25 seconds. What's the force? You're going to use this exact same equation. You're going to say that from rest, 0, the VF is 8 meters per second, and the time is a quarter of a second. Find the force, and you'll solve that one out. And that's enough for this recording.